So let's identify a function that you would like to work with and approximate using, let's say, n equals 4 subintervals. I also need an interval. So whatever the interval you would like to choose, that's fine by me. And a function.
How about -1 to 3?
Okay.
X to the 4th.
Yeah, let's make it a little more interesting. X to the 4th, e to the x. Okay. So we cannot, I shouldn't say we cannot today integrate this. We will in Calc 2. So let's say the integral from -1 to 3 from x to the 4th e to the x dx. This will be the exact area. Is this function continuous on -1 to 3? Yes, it's continuous everywhere. Perfect. So we don't know how to integrate this right now. We want to. The question is only asking us to find an approximation of the area under the graph between -1 and 3, of course, and using 4 subintervals. So here it is. This is -1 and 3. I divided it up into 4 subintervals. Why? Because delta x or dx, if you want, it doesn't matter, right? We're using delta x now. It's 3 plus 1 divided by 4. B minus a over n. So delta x is b minus a over n. B minus a over n. So far, so good? Okay. So now what do we want to use? We have 3 options. We can use the leftmost point, we can use the rightmost point, or we can use the midpoint. The midpoint, very good. So we're going to use the midpoint. So the area with a midpoint with 4 subintervals, a, m, 4, a sub m sub 4, is delta x multiplied by, which in this case is going to be 1, multiplied by, since this is -1 and this is 0, this is 1 and this is 2, the midpoint here will be -0.5, this one will be 0.5, this one will be 1.5, and this one will be 2.5. So then I have f of -0.5 plus f of 0.5 plus f of 1.5 plus f of 2.5, and I'm done, where delta x is 1. Now let me show you how I would do this with a graphing calculator. So James, is this clear? That's all you need to do.
Wait, so what does, so A is area, big M is, what was that?
Midpoint with
Oh,
4
yeah.
subintervals.
Okay.
Better? But is the rest clear?
Yeah.
Okay. So here's how I would do this. And yet you have several options. You don't have to use mine. But here's what I would like to do. In stats, I would like to edit, and I will add the list of negative, I'm sorry, I wrote -0.4, but I meant 0.5, of course. So I will write -0.5, then 0, then 0.5, sorry. Then 1.5, and then 2.5, yes. 1.5, and then 2.5. Enter. So then I would go to list L2 at the very top, highlight the top. And in there I will put exactly what I have to do with x. With each x I have to raise it to the 4th power and multiply by e to that x. So I'm going to write second and list caret 4. This is my x to the 4th. And now multiply by e to the x. And my x is, I have to put it in parentheses, you know me already. So what does this represent? Is x to the 4th times e to the x. And it will do it for all of them. When I press enter, all four numbers will pop up. I don't have to do this by hand. So now what I want to do is I want to sum them up. And all the information that I would like to sum up is in list L2. So what I'm going to do is I'm going to go to stats again, and now I want to calculate, and I want to calculate one variable stats, but I want list L2, second L2, and I calculate. Which of these numbers is what I'm looking for? Because I see a lot of things. Is it number 1, number 2, 3, 4, 5, 6, 7, 8? Exactly, the sum. So in our problem, we will get 498.7082. Now, if you would like to do this again, I can do it again. If you say, I don't care for it, that's fine too. I will not get hurt. I will not take it personally.
Can you do
Yes?
when you put it in L2?
Yes.
what equation?
Yes. So when you go to stats and you go to edit, so after you put in the x values, now notice one other thing. I only considered x to the fourth times e to the x, only because delta x was 1. But if delta x is 5, then in L2 I will write 5 times, so that delta x is also multiplied and put in the problem. So it's delta x times f of x1 plus delta x f of x2 and so on and so forth. But I didn't do it this time because delta x was 1. So what I put in is the function. The function is x to the fourth times e to the x. So x, all my x values are in L1. So second and L1, caret to the fourth power. And then don't forget to come down from the power. I always forget to do that. And e to the x, and in parentheses, although you may not need parentheses. So x is also in the power of e. So this basically means x to the fourth, e to the x. And once I hit enter, I get all four numbers at once. And then I can create a sum. So there are other options. I think that this calculator, my calculators don't have the sum. So there is another option with creating the sum, summation notation. Is it under numbers? Yeah, so this is it right here. Oh, I didn't mean to put it in there. So math, numbers, scroll up. No, I think it's in math. Scroll up, yes. So my calculators don't have this. So you can put this already, and you can write x equals from, what was it, from
Instead of the y input, we use the y bars. Or it says essentially the same. We're gonna do the.
so it's from 1 to 4, blah, 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 and you probably can put L2 in there. I'm not sure. I haven't tried it this way. Yeah, so that's probably another option. I have not tried it.
With L1 as
Okay, so there may be an option other than what I just showed you. But I prefer the stat. I also teach that, so I use that a lot.
What about
Yes?
the
Is this clear now?
Yes.
Okay.
That's clear. But what about finding the upper? I wanted to go over.
But then you have to find the left, the area with the left and the area with the right. So the area with the left 4 will be f of -1 plus f of 0 plus f of 1 and plus f of 2. And you have to determine this. And times 1.
For the right, it would be 0, 1.
Yes.
F of 0.
Yes.
2, 3.
F of 0 plus f of 1 plus f of 2 plus f of 3.
And the upper one would be the
the one that
Whatever I get.
whichever one's greater. It's way easier than I thought.
That's for the first one, so.
Good. Anything else? Is there anything else before we start this? Yes, anything.
That's
There
Any problem.
there's a function that's the math that you want to solve about to give you just just
I think it was velocity or acceleration problem where it goes the speed of the vehicle goes down.
Yes, so you have to just estimate the same way. Base times height, whatever height you want, whatever number of intervals you want, whatever is convenient. But you just keep in mind it will be an estimate.
Okay.
So you can use, I don't know, 6 intervals and use the midpoint and just estimate that. Or you can use 6 intervals and use the leftmost point or the rightmost point.
Okay.
So just make it easy so you can easily read from the graph.
Or could you use the definite?
This is the definite integral, but you can only estimate it because you are not given the function.
Okay.
So it is the definite integral.
Is the definite where? Thought that was where n approaches infinity.
Correct.
Yeah, that is.
Yes, that is the same. Yes, is the limit of the Riemann sum or the integral. So let me write that one more time. So a equals the integral from a to b from f of x dx, or the limit as n approaches infinity from the sum from I equals 1 through n from f of xi times delta x. They are the same indeed. The limit of the Riemann sum and the definite integral are the same. Is this better?
Yes.
Okay.
And
Yes.
what was dx again? The
The-
differential.
Of x, the differential of x.
So what?
So this
It was like.
is the same with
like
this.
X prime. Or it was like f prime of x prime.
That is a
Like those
differential of
parts.
y. So f prime is one thing, but dy is f prime of x dx.
Okay.
So this is the derivative of f, but this is, or y prime, and this is the differential of y. Better?
something other than.
Okay. So what do we continue with? What would you like to continue with? Anything? Anything that you tried or, yes, please, Robbie?
66.
Yes?
in the packet on page 413,
4 to 13, 66.
414.
414, 66. Very good. Okay. We did that in class last time and I didn't
All right.
even tell you.
All right, that's fine.
Next question. Okay, if you don't have anything else, till you find something else, let's start with this. Okay, let's work on number 1, 2 minutes. And then we'll do it together. We all have this, right? Okay. Do you have anything else before we start? Okay, so let's start with this. Let's do number 1. You have it?
Test 4. Practice test.
I did set up a review. I don't want to forget. For December the 8th at Randall Mills, though, in room 401 from 11 to 12:30. Please do come if you have questions. So it's not going to be something like, okay, let's do this, okay, let's do that. So I will answer all your questions. So if you have a list of questions, please do come. It's a Saturday, December the 8th, in the Randall Mills campus. I reserved room 401. Just in case we need to review more for the final. but I will answer your questions. I will not have a packet or something for you. I want you to say, okay, I reviewed my tests 5 times and I still have difficulties with, or I would like to see such and such. Is that okay? Okay, so please do come. Let me know when you are ready so we don't waste time. We just started working on this. You have it, right? I gave it handed it out last time. Okay. So we are on the first problem. Can we work on the first one or not yet? We need more time? Okay. Okay, ready? So I'm given the acceleration. I will have to find the velocity. So which function prime is 10 sine t? And that would be
So negative cosine.
negative 10, very good, cosine t, plus 3 sine t, plus a constant c1. I don't have any information about v, so I have to continue. So now I can finally find the function. So this was the acceleration, like the second derivative, this is the first derivative, and this is the function. So negative 10 sine t, right? Which function prime is 3 sine t, so it's negative 3 cosine t, plus c1t plus c2. Do we agree so far? Yes? Tom, go ahead, please.
I guess
You have the right to disagree.
I'm confused as to why, I'm sure it's obvious, but why the antiderivative wouldn't be negative cosine of 10t or as a possible solution
You mean from here?
from the first step.
Okay,
From
so
sine to negative.
when I differentiate cosine, I get negative sine.
Right.
Times negative 1, I get 10 sine.
Right.
Then here, when I differentiate sine, I get cosine.
Right, well, more I'm saying, could you have 10 as in it'd be a nested chain rule derivation?
No, because 10 is just a constant outside. It's a factor.
Okay,
10 is just a factor outside.
gotcha.
So then 3 sine t prime is this, and then sine c1 prime is 0.
Okay.
Now from here, when I differentiate this, I get negative 10 because sine t prime is cosine. When I differentiate cosine, I get negative sine, but times negative in front will be this. When I differentiate this, I get c1. When I differentiate this, I get 0. Better?
Yeah.
Very good. So now I have two conditions, two pieces of information, right, given for this function. So 0, when s of 0 is 0. So now let's see. When I plug in 0 in sine, what do I get? Perfect. When I plug in 0 in cosine, 1. So I get a negative 3. When I plug in 0 here, I have 0. So plus c2 equals 0. That clearly states or gives us c2 being 3. So now at this point, I have s of t, which is negative 10 sine t minus 3 cosine t plus c1t plus 3. It's not done, but this is where we are right now. Is this okay? Okay, so now I have one more piece of information, which is s of 2 pi equals 12. So let's go back to what we have, the new form. When I plug in 2 pi in sine, it's like plugging in 0. 2 pi or 0 is the same thing for sine. So what do I get? 0. Very good. When I plug in 2 pi in cosine, times negative 3. And here, when I plug in 2 pi, I have plus 2 pi c1 and plus 3 equals 12. These two go away, and I will divide both sides by 2 pi and get 6 over pi. So at this point, I have the entire function, s of t, negative 10 sine t minus 3 cosine t plus 6t over pi plus 3. And this is not the most general antiderivative. It's the exact unique function that has the given acceleration as second derivative and complies with the two given conditions, s of 0 is 0 and s of 2 pi is 12. Do we understand this problem? This comes from 4.9 from antiderivatives. Okay? Okay, moving on to number 2. Find the area under the graph of function f of x, blah, 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 on the interval, blah, 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 using the limit of the Riemann sum. So we're given f of x to the third plus 6x plus 3, and the interval is 0, 3. Just want to make sure that we finish today, so we would like to pace ourselves so we can finish the entire packet today, okay? It's not a lot, there are only 8 problems, but some of them require. Can I just get you on the right track? So remember, in this situation, there are 3 steps that are absolutely necessary in, like, the prep steps, right? When you get in your car, you don't start till you adjust your rear view mirror, your your seat, your so on and so forth. So we need the preps. So what is the first prep?
Make sure it's continuous.
It is a function that is continuous, yes. Yes.
Delta.
Delta x. Very good. Remember, b minus a over n. b minus a over n, or 3 over n. That's the first prep. What is the second prep? Xi indeed. Remember, x1 is 0 plus 1 delta x. x2 is 0 plus 2 delta x. x3 is 0 plus 3 delta x. And then xi must be, yes, 0 plus I delta x, or, in other words, 3i over n. And then the last prep must be f of xi. So now you know where all this is coming from, right? From the limit of the Riemann sum. And then we put them together. So what will you write for f of xi? No, f of xi first. I have not finished this. Maybe you're way ahead, right? But I have not written this yet.
Oh, it would be, so you would plug in 3i over n.
Very good, and raise it to the third, plus 6 times 3i over n, and plus 3. Now, let's simplify this. Are you there yet to simplify it? Is it simplified? Yes? Already? Yes? So 3 to the third, 27i cubed over n cubed, plus 18i over n plus 3. Now I can say the area is the integral from 0 to 3 from x to the third plus 6x plus 3 dx, which I should calculate now or at the end, because I would like to check my work. As you know, with the limit of the Riemann sum, I can make an error very easily, right? So let's do that right now. So this is x to the fourth over 4 plus 6x squared over 2 plus 3x from 0 to 3. I'm happy that I have 0 as the lower limit, so I only have to plug in 3. So then I have 81 over 4 plus 27 and plus 9. The least common denominator, so 81 divided by 4 plus 36. The least common denominator is 4, so 81 plus 36 multiplied by 4. And I'm lazy. How much? 81 plus 36 times 4. I doubt, but that's okay.
25.
Okay, it is. Very good. So this is what I expect. So this area now must equal limit as n approaches infinity from the sum from I equals 1 through n from delta x or f of xi times delta x. Doesn't matter. The order is not important. So 27i cubed over n cubed plus 18i over n plus 3 and multiply by delta x, which is 3 over n. So are we working on this now? Do we understand all steps till this point? Any questions? Okay. So let me just give you a couple of hints. I would recommend put 3 over n in front of the summation notation because it does not depend on I. It will not change, right? It's always fixed. And then put the sum on I cubed and 27 over n cubed in front. Would you like to work on this for a minute? Okay. Okay, should we work on it together? Yes? Do you want another minute or should we work on it together? What do you recommend? Did anyone get the 225/4? Okay. So I copy the limit as n approaches infinity, and I put 3/n in front. Then I open a bracket, or brackets. Ready? When I put the summation on the first term, this portion is a constant, so it comes outside. So this is a sum of I cubed. When I put the summation on the second term, the constant 18/n comes out, and I have the sum of I. And now I put the sum on 3, which means 3 is outside and the sum of 1. So this is the next step, in which we will have to, of course, this is from I to n, from I equals 1 to n, from I equals 1 to n. And now at this point, I have to eliminate these, replacing them by the corresponding formula. Are we okay with this? What do I replace the first one by?
And times quantity n plus 1,
Yes?
all over 2.
And everything squared.
Everything's
So let's write it like this. Very good. Awesome. Perfect. What about the second quantity? What do I replace it by? It happens to be the same without the square.
N times n plus 1.
And what do I replace the last one by? Very good. So now the summation notation or the sigma notation goes away. It's gone because we replaced it by the corresponding quantities. And now the algebra. So limit as n approaches infinity 3/n. Still keep the brackets. And then I have 27/n cubed times n squared, n plus 1 squared over 4 plus 18/n times n plus 1 over 2, n plus 3n. I'm going to delete that. I didn't have enough room. Are you surprised? No. Good. Neither am I. Good. So now I have to figure out the least common denominator, but I will simplify this with 2 of those. There is no point in simplifying here because I still have an n left. So the least common denominator appears to be 4n. I only have 2n here, so I have to multiply by 2. And this one has denominator 1, so it needs to be multiplied by 4n. So this is limit n approaches infinity, 3 over n, and 4n in the denominator. And I'll wait for you to tell me what to write at the top. Okay, ready? So this part is clear. I have to expand n plus 1 squared, and I get n squared plus 2n plus 1, correct? And I have to distribute 27. So 27n squared plus 54n plus 27. This is this piece. So 27 times n squared plus 2n plus 1. Now this piece, it's 36 times n squared plus 36 times n plus 36n squared plus 36n. And of course, I have to write above plus 12n squared. Do we all have this? Okay, so now combine like terms. So this is limit n approaches infinity. The denominator now is 4n squared. And then I have 3, and in parentheses, 27 plus 36, and plus 12. What do we get? 27 plus 36 and plus 12. How much?
63.
6. Is it?
63.
What is it? Okay, so this is 48
Oh, plus that.
plus that.
Yeah, give myself that.
Very good. 65n squared.
75.
Okay. My apologies. And then 54 plus 36.
56.
54 plus 36.
90.
90, very good. And plus 27. So this was 7, but I have to let it dry. Okay. So at this point, I can say, I know from pre-calc, same degree over same degree, the horizontal asymptote must be 3 times 75 over 4. If that's 75. Is it 75? So what did we get with, yes, is it the same? Okay. Then it must be correct. Good. Is it clear? Yes? Okay, very good. Let's move on to the next one. We are given a function that is a piecewise defined function, and we're asked to find the integral from 1 to 5 from f of x dx, and the function is given to us 1 over x squared plus 3x for x less than or equal to 4, and the square root of x for x greater than 4. Okay, 1 minute. Can anyone give us a hint on this? What is it expected of us to do here?
Find the middle value from that. And then
So we have the integral from 1 to 5. So how will I write it?
24 and then 45.
Yes, exactly. From 1 to 4 from a certain function, plus the integral from 4 to 5 from a different function. So we have to determine two integrals. So let's determine two integrals. Right? So the integral from 1 to 5 from f of x dx would be the integral from 1 to 4 plus the integral from 4 to 5. Of course, dx from what? The first one.
1 plus 3x cubed over x squared. Doing it easy.
1 over x squared plus 3x. And the other one is square root of x. Agreed? Okay, now we have to determine these two definite integrals. If we're done, I can continue. Or do we need another minute? Another minute? Which function prime is 1 over x squared? This is one of that very important list. Awesome. Plus 3x squared over 2 from 1 to 4. Plus, now the square root of x, we should remember that this is x to 3 halves over 3 halves from 4 to 5. Do we want to fill in, or can we do that later so we can continue? Can I just write it and then you calculate the numbers later? So first we have to plug in 4, correct? Because I just want to make sure that we complete this. So negative 1 over 4 plus 4 squared over 2, so 3 multiplied by 8. And then minus when we plug in 1, minus 1 plus 3 halves. And then plus when I plug in 5, so it's 5 times 2/3 in front. 2/3 times 5, 2 3 halves, but minus 2/3 times 4 raised to 3 halves, and I'll let you finish it later. So one more time, we plugged in 4 in both, and we got this, minus, when I plug in 1 and I get this, plus, I plug in 5 and I get this, minus, I plug in 4 and I get this. We can come back and finish it up if we have time today. If not, can you finish it on your own? Okay, evaluate the integrals or find the general antiderivative. The integral from 1 to 5 from 5 minus 2t plus 3 squared dt. It's problem 4a.
Oh,
Just one more word.
just 1 to 4.
Yes. Sorry about that.